I'm going to show you how you can use the inference line to address the issue caused by life loads. First is a concentrate life load. So using a cross-section moment, bending moment MB as examples. So this is the inference line for MB. So if I have a life load with a magnitude of 1 acting at this particular location, so the inference line tells me that the magnitude of MB is equal to that value. If I move the loading to another location, then the magnitude of MB is equal to this value. And the third location. Similarly, the magnitude of MB is equal to that value. What if the magnitude of the loading now increased from 1 to P? So according to linear superposition principles, all you need to do is to take the magnitude of MB that you find on the inference line at that particular location and multiply by the magnitude of the loading. Then that will give you the magnitude of MB under the actions of this concentrate life load. Next is the distributed life load. Assuming that I have a distributed life load with a magnitude of W acting at this regions of the structure. So what is this effect on the magnitude of cross-section MB? So take a small strip of the loading, dx. So this small strip of loading is going to come with a magnitude of W times dx. So you can regard that as a concentrate life load. So it can go to this particular location and pick up the magnitude of the inference line and multiply that by the magnitude of this strip load. So the magnitude MB equal to Y times W times dx. So you can perform all this strip loading from left to right, which then leads you to an integration expression. So it tells you that the bending moment MB under actions of such a distributed life load is equal to the integration from x1 to x2 y times w times dx. If the distributed life load comes with a constant magnitude, you can pull w out of the integrations. So that gives you expressions MB equal to w times integration x1 to x2 y dx. Note that this integration is nothing but the area underneath the inference line for this region. Note that the area calculation comes with both positive and negative. So with this equation, then it helps you to answer these questions that the effects of the distributed life loads on a particular internal force or reactions.